In this video, we are looking at polar coordinates, and the objective is to differentiate between polar and Cartesian coordinates. So let's start with rectangular coordinates. And this is a coordinate system in which the coordinates of a point are its distance from a set of perpendicular lines, the x and y axis, that intersect at the origin. So let's give an illustration of that. So if this is my xy axis, if I have a point 1, 2, 3, 1, 2, and this is my point here. Suppose the point is 2, I mean not 2 but 3, 2. So those are the coordinates. What does this mean? The y coordinate, the x coordinate is the distance from the y-axis. So it's 3 units to that point. See, this is perpendicular. And then for the y coordinate, the 2, it's the distance from the x-axis, 90 degrees to that point. So that's the rectangular coordinate. The next one is called the polar coordinate system, and this is a plane with a point of origin called the pole. This is the pole, and a ray from O called the polar axis. So you can see the polar axis right here. And instead of xy coordinates, we have 2 new coordinates, the distance and the angle theta. And you can see the polar axis instead of the x-axis like we had over here in the rectangular coordinates. Here we have x, y. So here you can see we have polar coordinates and an angle. So here, where do we apply these ones in life? So polar coordinates are used in investigation, as the destination or direction of travel can be given as an angle and distance from the object being considered. And aircrafts use a slightly modified version of polar coordinate system for navigation. So they can be able to measure the distance of an object from the plane itself. The plane becomes the pole. Okay, so here, how do we graph these points? We have a set of coordinates here, and we need to figure out how to graph them. Let's do a closer look at the point. So remember, this is the distance, the radius, and this is the angle. This is the radius, this is the angle. Okay, so here we have 2 and pi over 4. How are we going to show that? So point P is, I need to look for pi over 4. So pi over 4 is right here. And the radius is 2. So I measure 2, 1, 2. And then I'm going to put a dot there. So that's going to be right there. So that's point P. Okay. Now let's look at the other one. What are we supposed to do? We are given negative 2, 3 over 4. What does it mean? Remember, the distances are always positive, but this one is negative. It means it's negative radius. What does that mean? Let me illustrate. So here, I look for this angle, 3 pi over 4. So 3 pi over 4 is in quadrant 2. And I see the radius is 2. But instead of, so the radius is 2. So 1, 1, 2. But instead of going in the positive direction, would be a radius of 2, I'll go in the opposite direction. So the same angle, but I'll go in the opposite direction. So I just follow the line, go in the opposite direction. So that is how we denote a negative. So I look for 3 over 4, and then I go in the opposite direction because that's the negative radius. So that's point Q. Okay, let me now go to the next one. The next one is 3, 180. So 180 is pi. So 1, 2, 3. So the point is going to be 1, 2, 3. So that's going to be the point R. And let's go to the next one. The next one is negative 245. What does that mean? That's negative radius. So then I go to, let me do the ones with negative in blue. So I go to 45, and then I go to the opposite direction, and this is negative 2. So it's like the opposite of the first one. Just make sure I'm on the correct spot. So 45 opposite. Okay, so right there, and that is point S. Again, negative radius. And that's all about how to graph the points on the polar system and how to differentiate between polar and the coordinate system.